So we chose the Kenyan pyrethrum sites for our PSP project. Our problem definition was to determine locations suitable for growing pyrethrum. Our input is a sequential file with rainfall and elevation data for multiple locations. Any intermediate data required can be calculated from these values. Since we know the ideal growing conditions, our program needs to evaluate each location for suitability. So after our programs run, this is what will be output for the user. So firstly, a text file containing all the locations from the data with the suitability, either yes or no, whether it's suitable for growing the pyrethrum or not. The user will also have a print screen output, which will include the total number of locations evaluated successfully, the total numbers of locations not evaluated due to error, and the number of locations suitable for growing pyrethrum. So this will be the layout of our program for the user. It'll start out with an input of a file location. The user will be asked to input the file location, and then the program will output that the file was found and can be analyzed within our program. So then in terms of an output layout, we'll have a certain number of locations were evaluated, a certain number were skipped, and then we'll output the number of locations where it is suitable for growing pyrethrum. We'll also share with the user where our text file will be stored so they can go look it up.
So this is the basic flow of our program, how it'll go through. We'll have at the start, it'll prompt the user to enter a sequential file, and then we'll run some error handling and have some sort of function or block of code that converts the files to lists. And that'll output a rainfall list and an elevation list. We'll do, more error handling to make sure that all the values were retrieved properly and that all of them are in reasonable ranges. Then the elevation list and rainfall list can be put into a function which will determine the moisture availability zone. As well, we can determine the temperature zone. We only need the elevation list to input in order to determine that. And those will output a list of integers, just basically zone classes for each of those. And then further down the line, we'll figure out whether each location is suitable or unsuitable using inputs from those two lists. Basically, if the moisture zone is 1 or 2, and if the temperature zone is 3, then it's considered suitable for growing pyrethrum. From there, we'll be able to do 2 final outputs. One of them is just outputting to a text file each location on a new line and whether or not it's suitable. And the other one is showing the results to the user, just print on screen the locations evaluated, the number that were skipped, and the number that were suitable. And some of this is going to come from the error handling that we did earlier. We'll have some count functions there.
Okay, for error handling, our assumption the file will be formatted a certain way. It only contains relevant data separated with spaces and commas. For error handling, data input is the file name location. Make sure it's correct and valid. The data formatted correctly. Values are appropriate, no extreme values, no zeros. For example, sea level is 0, of course, and then Mount Kenya is 5,199 meters above sea level, so as long as it's within that range, we know that we're working with good material. Now this is an example of our test values: location, mean rainfall, elevation. Our text files, location 1 is unsuitable, location 2 is unsuitable, and print results, 2 locations evaluated, skipped, and so end result is 0 locations are suitable for growing.